Okay, good morning, everyone. So welcome back to RoboCup at Home Education Online Challenge 2020. And today is the online classroom for open platform. Right. I would like to say thanks for our sponsor. And today we are going to deliver you on the topic robot speech interaction. And okay, let me show you the content. Next slide. Okay, so today, as usual, we will separate into two main topics. So the first one is speech synthesis, which is pretty short. So maybe it will end in less than 1 hour. Then we will straight away head to speech interaction, which is much longer. And today also, I'm very glad to invite engineers from Jupyter Robot that are going to show you a lot of cool extra content. Okay, so this extra content is something that not in the regular class, that you can see some very interesting application and example on how to build robot chatbot, or how to say speech assistant that you can build just with your PC and some cloud services. Right, so today the speaker will be me, Jeffrey Tan, and also our colleague in Jupyter Robot. So we have David that is going to show you some extra demonstration and also explanation. Okay, then so we roughly estimate for about 2 hours of class. We have the Zoom link over there. So just in case that you want to invite your friend, your colleague or whoever, your student, so please copy the link to them, and also the password, not forget the password. We are also online now on Facebook Live in our group. So if anyone that without the software, you can see our live over there. And for the materials, okay, so for the first link is on the competition, the Online Challenge 2020. So that link will link to the particular information if you want to join the competition. And over here, I would like to invite you to please send in the entry application, okay? Because we have a lot competition related information will be sent by email to the group who sign up for the entry application. Okay, because that is more detailed and also more information about particularly on the competition. So we will send it to the team. So just in case that you still consider whether if you want to join the competition or not, I will encourage you to sign up first. Okay, so go to the website. There is an entry form, and at the end of this slide also we have the link to our entry form. So please sign up the entry form first to put down your email so that we can contact you to tell you more about the competition. We have a lot more competition, for example, like competition-based source code template, and also how to submit the thing and the timeline and so on, that we will first priority to communicate directly with the team leader. So please remember to sign up first. Okay. Then the last link that appear on this slide is our online classroom. So you will have the information about, for example, the slides that I used today, and also some other information, the timing, the time schedule, and so on. And you can download the PDF as well. So for your own use and so on, you can pass it to your friend or for your student. Okay, so all the information will be there. And also, if you head to our online classroom page, you can also see we have other classes that is currently running in parallel. So we have the Pepper, which is the standard platform, and also we have classes in Mandarin. So just in case any of your colleagues, student, or anyone that prefer or want to hear the content in Mandarin, in Chinese, you can also hit, you can also find a link of the information, the timing, and so on over there. Right. Okay. So last, as a reminder, this whole session will be recorded. Well, we are on the Facebook Live as well. That video will be also recorded. So everything will be recorded and we will publish online. So make sure that you safeguard your privacy. Okay, so let's get started. Next slide. Okay, so first is I need to check like your preparation. So previously, whether if you have attended the previous session or not. So previously we have given out this assignment, which is we show the class how to develop ROS package and the first package. Then after that, we ask the class to develop the publisher and subscriber nodes. So with that, we're able to create the first ever node, ROS application that able to pass the message between two nodes. Okay, so that is the assignment for the previous class, and this will be the fundamental or the prerequisite for this class. So at least you need to know how to do such development in order to continue the development for today's class. So just in case that you are first time enter this class, maybe you want to have a look at the video, the recorded video for last week, which is you can find on the online classroom website. So you can go there and have a look on the video, and also the materials. The PDF is over there. So just to refresh yourself on how to write the ROS package, and also the right to develop the ROS node on to do publisher and subscriber. Okay, so that is the fundamental thing. And also as an extra, if you would like to learn more about how to manage your coding, so I will recommend you to create a GitHub account and try to learn how to actually use Git and GitHub to manage your source code. So it is a easier way for us to communicate as well. So you can like show us your code in GitHub without transferring a lot of files and so on, and we can discuss over there. Okay, right. So that is your preparation. So let's start the first slide for today. Next. Okay, so for today class, we need to prepare certain hardware and software in order for you to start your development. But you can see it is a very simple hardware that are required. So similar to last week, you just need the laptop PC that run your Ubuntu and ROS, right? So if you want to skip all the step of installation, you just get the VirtualBox image from Jupyter Robot, and you put in and run it, and you will have all the software installed and configured nicely for you. So you can straight away head to the start for the development. But for today, we require additional hardware, which is the speaker and microphone. But this hardware, I believe most of the modern laptops already have. You already have the speaker and also the mic built into your PC. So later on, I will show you a way in Ubuntu to test, to make sure that your speaker and microphone is working fine with the system, and you're able to use it for our development later. And also today we will use some other software within ROS, in ROS and in Ubuntu. For example, the speech hardware and also the recognition hardware and so on, which is I will introduce along the slides. But if you are using the VirtualBox from Jupyter, you already have all the software installed. But I will introduce to you what actually are the tools that you are using, okay, throughout the whole session. Okay, next. Okay, so start from the first module, which is the speech synthesis. So what is speech synthesis? Is actually in simple form, we always call it text to speech, or we call it TTS. Okay, text to speech is a more common name to refer to such system. So speech synthesis is the production of artificial human speech by a computer or other machines. So whether you have a Raspberry Pi, or you have an embedded system, or you have a desktop computer or laptop, or your robots. Okay, so this machine that if we can able to run our system, the Ubuntu, and also our development system, the ROS system, so we able to install the software and configure and develop the source code in order to achieve this speech synthesis. So you have software that can run on this machine and help you to do this synthesis, which is it will convert. So for example, like in a text to speech system, it will convert normal language text, right, into speech, human speech, and read it out. Okay, so for this speech synthesis, the whole process might be a bit complicated technically. Okay, so if you want to open it out to understand what happened in the underlayer software, it might be quite complicated, right? So it is not as simple as how to convert, right? So first, you input text into the system. Okay, so in general, so this is in general, because different software, different system, they will use different architecture and also different way. But in general, a general concept of speech synthesis is like this. So please refer to the diagram on the slide. So the first is like we have to go through text analysis. So it will analyze the text. It will try to pick up the word, the spacing, the keyword, and other things to see whether it's a phrase, it's a word, it's a sentence, and all the other things. right? So it do the text analysis. Then linguistic analysis. Linguistic analysis is more on, is one step after the text analysis where it try to identify whether the grammar of the sentences, okay, that you inputted, for example, or also like for example the punctuation, and also to see, for example, the same sentence you can be it can be a sentence that is a statement, or it can be a question, right? And the whole the wording, the phrase, and everything looks similar, except like in a question, maybe you put a question mark behind. But in terms of pronunciation, we actually need to pronounce it differently, whether it is a question or a statement, right? So this linguistic analysis will help the system to understand how to read the sentences in a more appropriate way, okay? In terms of matching the intonation, the speeds, and so on, and what keyword to stress on, because you have some certain keyword important, which is, for example, your verb, or your subject, your predicate, and so on. So we need to know where to focus on. Then lastly is the waveform generation. So you know all the requirement, like what is the speed, what is the pitch, what is the tone, and so on. So we need a waveform generation, which is we already have maybe a library of on certain pronunciation. Then you try to gather, assemble them, and generate the waveform in order for the speaker to read out. Then you will get the speech. So this is the whole process how you convert from a text to speech, right? Okay, so how this thing can be done on your machine, right? So let's go to the next slide. Okay, in Ubuntu, we already have this function or this software installed in Ubuntu system, which is over here we call it the festival. So if you are interested on this festival framework, you can head to the official site, which is I put up on the first link. So on this slide, it explains like what is festival system and how it convert, or how it execute, or how it develop the whole system that I just explained just now, right? So how to do the speech synthesis and so on. And on the website, you can see even more. For example, like you can see the language package and other things. For example, if you want to customize the speed, customize the system, customize a lot of things. And even, if I'm not mistaken, you can find support for other languages as well. So on the website. So you can head to the website and know more about, if you are interested on the algorithm, on the calculation, how the whole thing is being developed. You can always refer to the website for more technical information. Okay, but over here, we just focus on the implementation. So I show you where is the place to find more details and also info that later on you can refer after the class. Okay, so the next thing I would like to introduce you is the ROS wrapper for this festival. So in order for this software to use, that you can develop in ROS system, we need a wrapper. So this SoundPlay is a package in ROS that use this sound function and to provide you a speech synthesis functionality for your development in ROS. Okay, so you can head to the ROS wiki site to see the detail on this SoundPlay. Particularly, I will recommend you to read the tutorial, okay, which is I put on the link below the SoundPlay list. Sorry, the SoundPlay website. Okay, you can see there is a tutorial link over there that I recommend you to have a look on the tutorials. Okay, because the tutorials will give you all the information, especially the explanation of the API that you can use in your development by using SoundPlay, right? And my example that I show you here over here is also referred to the example in the tutorial. So if you want more information, I encourage you to read the tutorial. Okay, so first thing, installation. So for those that you try to install this software, try to set up this system by yourself, you can do the installation, the software over there. Okay, so that is something that you need, which is the ROS Kinetic Audio Common. Then you will have all the stuff that you need, right? So then we will start with the command line operation, and also I will follow with the source code implementation. So what for all the module, I will try to show you both ways. So how to run it using the command line operation, which is to show you the effect on how this functionality works in ROS. Okay, so you need the ROS call and run the package, the nodes, and so on. But at the same time, I also prepare the example in terms of the source code, and I will show you what are the source code that we use to develop this function. Okay, then we will show you how to do it, and we will show you the source code. I will explain the source code so that you can develop this function for your robot for automation, for automatic system, right? So I will show you the source code after this. So first, let's us bring up the development environment. Then we'll show you how this speech synthesis work in command line operation. Okay, so on the right hand side now, you can see we have the Jupyter robots operating system, the operating system in the Jupyter robot virtual machine. Okay, so from there we can run the terminal. So you run all the command from the terminal, right? Okay, so first you run the ROS call, then after that you run the ROS run the sound play package. So we'll use the function in the sound play package, which is the first one. We run the node of this sound play node.py. Okay, so this sound play node is similar to the rest of the module that we need a bring up. So a bring up is to start certain module, okay, to get ready certain module. So when this module is ready, which means you can use the function of this module. Okay, so over here, you can see like when we run the sound play node, we are ready to play a sound. Okay, so and you can play many tracks of sound, which is I will show you later on in the source code. But over here, what we do is like we use the another node, which is what we call the say.py, which is inside the sound play package, and then we add one argument behind there. Okay, any. You can even add a long sentence. Okay, it doesn't matter. So over here, right. So David from Jupyter typed up this good morning. So let's hear what is the effect.
Good morning.
Okay, so I hope everyone can
you
hear.
hear that?
Can everyone hear? Good morning. Yeah, because now we are in different direction. I mean like different location, right? So I'm doing this live streaming in one location, and the robot is actually at another location, right? So I hope you can hear. So if you can hear anyone, please indicate us in the group chat. Okay, just in case that you miss it or it don't appear at your terminal. So please tell us. But over here I can hear it clearly, right?
Jeffrey, can you hear the good morning?
Yes. Okay, yes, I can hear. Right. So now after we run the node, you can hear like it say, okay, we have the 3 feedback from the terminal. Okay, let's see what is the feedback. So the first thing is we have the saying, which is the good morning. Then we have the voice, right? So the voice, which is the argument to determine which type of voice you want to use. So by default, if you didn't indicate anything as the first argument, the first argument is the phrase that you want the machine to read out. The second argument is the speech, the voice, right? The voice package that you want to use. So which voice package you want to use by default. If you didn't enter anything, so this say.py inside there will assume they will use the default one, which is you can set the default, okay, in Festival, but you need to do it in Festival, okay, right? So currently the default is this Carl diphone, okay, this Carl voice. Then the third one, which is the volume, over here we didn't set anything on the volume, so it is by default is the scale 1, which is similar to your sound card setting, right? So these are the 3 things, and later on I will show you how to change the voice and so on. But before this, I would like to show you your sound card setting, right? So maybe this is the first thing that we need to do, but it's okay. So David, can you like show us the sound card setting for input? Sorry, for output actually. This is output. No. The sound. Yes. The sound up there on the upper right hand side. Upper right side is not the source code.
Okay.
Yes, it's not the source code. It's the sound card setting to adjust your volume. Yes. Okay, sound setting, correct. Okay, so before you start, actually, you need to select the appropriate sound card for your this sound development. Because just now I said you require interface with your microphone and your speaker. So in order, if for example, if you run the sound test and you cannot hear anything, there is a possibility that you already mute your sound card. Okay, there is also a possibility that you select the wrong sound interface. So over here you can see the first step is on the output, which is which sound card. So we have multiple sound card in one machine, especially in our robots, we have multiple sound cards that it will go to. So over here, I think David is using a robot. So we have a USB audio device, which is the USB sound card. So he select the USB sound card. So make sure you select the correct sound interface for your output. And if you're not sure, select one and hit to the test sound on the right hand side. Right hand side, there's a test sound.
Jeffrey,
Yes.
I want to explain the USB audio device.
Okay.
Why there is a USB audio device? Because I mount a USB device at here. I can see click device. That is a different type of device list. Most of the notebook can use this audio and double check the audio input and audio output is also be checked. But if you want to get more, much more better result, maybe you can use another USB. I use this one USB audio device. This is much better than the audio device in my notebook. So after I mount this USB device, I can find there is a USB audio device in the output and also in the input microphone and the speaker. So that's much better than the speaker and the microphone in my computer.
Yes. So additional to David's explanation is currently we're using in on the robots that Jupiter robot offer. So they use the USB sound card. So USB sound card is actually a very simple device that is a USB plug-in. Then you have a two jack. One is for your speaker and one is for your mic. Because I also understand that a lot of modern laptop now come with a very weird sound jack. Okay, for example, you only have one, and you are going to share whether you want to put in a microphone or a speaker, right? So in order to make sure that everything can run smoothly, we always recommend you to use this USB sound card, which is much easier and it's not very expensive. It's a cheap device that you can find. Right. So once you plug in, as David pointed out, if you're using the VirtualBox system, make sure that you remember to check on your USB device, okay, in order for it to appear here for you to select. Okay, now let's do the testing.
You can test the sound.
Left, front, right.
And you can test the input of the microphone. If I say something that is there is something higher than in this area, you can drag this to set the value of the input voice.
Yes. So that gain, we will talk a lot more about the gain in the microphone for the next section on the recognition. But over here, you can select the bar to determine what gain you want, right, in order to amplify the input signal. But we will discuss this thing more later on in the second section. So first, now focus on the output to make sure that you can get the sound, right? So the setting, sometimes you forgot to set the USB device, or sometimes you set the wrong, or by default it is not on the device that you want. So you need to modify from here and make sure you test the sound in order to make sure that you can hear the voice from your machine. Okay, so this is the setting that you need. All right. Okay, so now we're able to run the speech synthesis, and yeah, you know all the argument that you can play with. Right. So now let's hit a bit further. The next slide will be show you how to use different voices.
Jeffrey, your sound look here not very good. There is noise in your.
Can you still hear me, everyone?
Yes, we can hear, but it's not clear. That,
yeah, I think it's the
lot of noise in the sound.
Yeah, I think it's the Wi-Fi.
Can you change another device? Change to
I
another
only
device.
have one Wi-Fi. If you need, I can log in with my phone, but I'm not sure would it be better. So just to check, can you hear me? For other participants, can you hear me?
Yes, we can hear you, but there is still noise.
Yeah, is it noisy? Or is it better that if I use I'm not sure if is it still noisy? Because I never changed anything.
A little better, a little better.
Is it better now?
Please go on. Please go on.
Is it okay now? Because I try to plug with my earphone. Do you hear me? Is it better now? Hello? Testing. Is it better now?
Okay, I think it's much better. Thank you.
Okay, so I'll try with this. Okay, so hopefully you can hear me clearly. So let's go forward the next step. Okay, so the next step is I will show you how to change the voice. Okay, so before you want to
Next.
change it, yes.
Next slide.
Yes, next slide, please. Okay, so before you're able to change the voice of your machine, you need to add the voice package, okay, additional voice package. And I put up a reference, which is you will head to Ubuntu forum for a very technical explanation, right? So it is a very technical post on how to add additional voices into your festival system. Okay, but you no need to refer to that detail for the current moment. So just listen to me. I'll explain to you in a very simple form first. Then only you decide which steps you want to follow, right? So in order to add the voice, we actually have two types of voice package. Okay, so the first type is the author of the voice package have created the depths, Ubuntu depths that you can use it for installation. So install by using this is very much simple because all you need to do is on your terminal, you just need to input the sudo apt get install and the voice package. So over here, I list down the voice package that you can use, which is over there, you have a Fastbox Don, and then the other one, KDL, BC, 16K, and so on. So these are the things that you can install. So David show you one way. Okay, so this is how you install additional voice package. So for example, I install this Don, D-O-N, right? So this is how you install. Okay, so it's very simple. So in order to verify if what voice package that you have installed, you can look at the content in that particular path, the festival voice path over there. Right, David, maybe you can show us like what is available in over there. The second line, installation by depth, the second line, second. Yes. The second line, installation by depth, not by voice message. Yes. Show the USR share festival voices English.
This one?
Yes.
Okay. Computer. US share. Festival voice.
Yes.
English.
So over here we have two. So by default we have the Cal diphone, and then now we have the Don diphone, right? So after you install, this folder will appear. So which means you have installed an additional voice package. Okay, so which is good. So now let's see how we can switch. Okay, so in order to switch, everything is the same. You still run your raw score, then you bring out your sound play note, everything is the same. But when you want to execute the save, okay, so you need to add an extra argument behind there. So that is how you do it. So you type out voice underscore, then you indicate the voice package that you want. For example, over here we indicate we type in the name, which is the Don underscore diphone.
Good morning.
Okay, so just to illustrate the difference, so can you run the default one?
Good morning.
Yeah, so there are different voice. Yeah, of course, like we can actually install more over there by depth, but I found that the voice that gives you a much better feeling is the one that you need to install by voice files. Okay, which is the author maybe didn't like haven't created the depths in the Ubuntu repository, so you can't really like install directly using the apt-get, but you can still do it by adding manually the voice file into the directory that just now I showed you. Okay, but I will recommend you to first read the reference to understand all the technical detail before you do this. Okay, so because over here you will need to do some operation that involves the system file, so make sure that you know what you're doing. So I already put down places that you can download the voice file. Over there have two series. So one is the CMU series, and another one is from the festivals, which is the original. Sorry, yeah, it's on the original festival repository, so that you can install. And also maybe some of you might want to know not just a male voice, but you want the female voice. Okay, so I already tested almost all the uh, example voice package that's are available, and I found that these are the few, right, that will provide you female voices. Okay, so you can hit over there. It's like the CMU, US, AXB, and so on, right? So if you install by manually by putting those file into your directory, your festival directory, then you can actually add additional voice file. And among them, these are the few that will give you the female voices. But I'm not going to show you the demo here because it requires some time to set up, but you can always try, right? You can download the file, unzip it, put it on the directory and try to run it. Okay, so and the whole operation is very similar like what we have done here. Okay, so this is how you do for your SoundPlay to run on the command line. So now let us see how you want to do this thing using source code. Right. So maybe David, you want to like go to the one page before this. Okay. Right. So the next the following part is a source code implementation. So we have prepared an example that is written in this soundplay.py inside the RC Home EDU speech module. Okay, so we have a package called RC Home EDU speech, which is inside our Learn ROS repository. So over here, got sound test. So let's look at the sound test apply. Okay, so for this slide, I'm not going to explain to you line by line, but I'll just tell you the important part. So the front part is about importing all the function. And over here, what you need to notice is we're using the SoundPlay, right? The SoundPlay, the library SoundPlay, and we have the message and also the library lib SoundPlay, right? So from there we import. And over here, what important is this sound client. So you have the function of all the SoundPlay through this sound client interface. Okay, right. Then we head to the main, which is first you initialize the node. Then after that, let's head to you can see a print say. Okay, so we have the sound handler dot say and hello world. So that is how you specify what the system need to read out for you. So by using this dot say function, you can read out the hello world. Okay, or whatever text that you enter here. You can enter one long sentence, is okay. Okay, but what you need to take notice is the sleep after that. So we have a sleep function after the sound handle say, and over there is written 3, so it's a 3-second of pause on the for your program execution. So we'll sleep for 3 seconds before you execute the next one. Why we need this sleep is because you need to give time for the system to read out your message, okay, in the sound, in the say, right? So you need to give like about 3 seconds for it to read out. Why you need this sleep is because like if you don't put this 3 seconds, so the sound handler will generate the wave file of this sound of whatever content that you want it to play. But when it start to play, the system actually start to execute the next one if you don't have the sleep. So if the system hit to the next operation, then it will terminate your whatever that the machine try to read out. So for example, hello world, but it tried to cut down hair, then it start, or maybe before even the system able to start reading out the hello world, it already start to execute the next line. So that will cut off whatever that you want to read out at that moment. So we need this sleep in order to give time for the system to read out the text that you have input. Okay, so that is the time. And how you want to adjust this time is depends on how long your sentence is. Okay, so you have your long sentence, then you need to put more times and so on. So you need to do this adjustment by testing on your sentences, and also depends on what sound, the speed of your voice setting and so on, right? So these are a few parameters. That's why there is no definite answer on how long you need to sleep. But of course, if you look at the tutorial, there is a way to do blocking and unblocking way of execution where you can block all other process until your say read out the whole sentence. You can do that, then you don't need the sleep. But I want to mind you not to use that directly. Is because like we actually found out that this blocking and unblocking might also affect the other operation. Yeah, because in our ROS system, when we run, we have a lot of node running on parallel and so on. And also even in one node, we have multiple things that are running. Okay, so if let's say you do the unblocking and blocking things, it might cause certain other operation to stop functioning as well when you are doing your say and so on. So that's why I don't put the unblocking and blocking method over here. It's because like it might affect some other things. But if you're interested to know more, yeah, you are free to head to the tutorial to know how to do this blocking method that you no need to specify the sleep. Okay, so just to tell you that there is such thing that you can do. If you are interested, you can find out more. Okay, but in a normal way, just use this sleep way. Okay, then after the say, we have other function that you can use with this sound handler, which is the wave and so on. So David now can run the code, and you can have you can hear what is the effect.
Hello world.
So this is a sing.
Beep.
This is a wave file. Some sound effect.
Moving low back. Test of the new API. Beep.
Okay, so these are a few effects. So David, can you like open up again the source code to compare what you have just heard and how it is actually written in the source code? Yes. So just now you can see after the say we have the wave a little bit up. Go up a little bit. Yes. So the second one is the wave. So over here you can specify a wave file that you can play out. Then you have this plugging, unplugging, and other things. These are the some how to say sound effect that you want if you want. And also down there there are some ways of the new. You can write this in this new API way, which is you can put it into instead of a sound handle, you need to write a very long thing. You can put it like S3, S2, and then you can run that. Okay, but those are just some additional information if you want to write in a different way. But in general, fundamentally, what you need is a say, and maybe you need a wave file to run certain to play certain sound file, or you want to use one of the sound effect as well. So these are the few things that you need in order to make your robot able to say things and interact with the people. Okay, so I guess that's all for this speech synthesis. So we can head to the next module, which is the speech recognition. Yeah, I think that's all right. Is there any more slide after this? Yeah, no more.